Let's step through the submission of an order from the user's perspective. We're going to order some milk and some sausage. In this case, our quantity for each product is 2. Now let's go to our checkout page. Our customer information form is on the left, and our subtotal and delivery charge are on the right. Before we submit this order, we want to make sure that we can validate the information that we place in the fields. We are going to do that 2 different ways. We're going to validate the information on the client side, and we're going to validate the information on the server side. For the client side, we're going to use Jquery and a Jquery plugin or library called .validate, or just the Jquery Validation plugin. Jquery is a JavaScript library that can simplify JavaScript programming by making the elements in your HTML document easy to access and to modify. This is the blurb from the Jquery website. As you can see, they emphasize document traversal and manipulation, event handling, animation, and Ajax. Another strength of Jquery is that many browsers have slight differences in their JavaScript engines, and Jquery developers do a good job of making it work well despite these differences. It is easily the most popular JavaScript library as of this writing. Jquery also provides the ability to make plugins for it, which makes it even more popular than it would be otherwise. The .validate form validation plugin is an example of a Jquery plugin. Using the .validate Jquery plugin, we're going to do some basic form validation on the client side of our application, so that the form cannot even be submitted until certain requirements are met. Here's an example of what happens when we do not enter data in a required field or when we enter invalid data. The name and address fields are empty, and the validation plugin is telling us that those fields are required. The text in the email field ends in an @ symbol, but the validator wants to see text after that symbol. The phone number is correctly written as a number, but the validator wants to see at least 9 digits. Finally, the credit card number has an appropriate amount of digits, but they do not correspond to a valid credit card pattern. Credit card numbers are not random. Different portions of the number have different meanings depending on whether your card is a Visa, a MasterCard, or something else. Note that the validator is not checking if the credit card number actually corresponds to a real active card somewhere. It is simply checking for a few basic patterns so that it can rule out numbers that do not even conform to those patterns. In addition to client-side validation of form input, we're also going to be looking at server-side validation. This is the response I received from the application when I turned JavaScript off and submitted the input you see here. Remember that all browsers give their users the ability to turn off JavaScript. So a best practice is to make sure that anything important the client can do using JavaScript should also be possible if JavaScript is turned off, though the results may not be as efficient or visually pleasing. In the Affable Bean project, we're going to handle server-side validation by creating a Java class named Validator. Suppose we fill out the form with information that passes all validation, as we see here. Then we should be able to submit the form to the server and have the server update the Affable Bean database. Keep in mind that just because the information from the form successfully passes the client-side and server-side validation checks, it does not mean that there won't be any problems when we try to update the database. This is only a first level of validation. For example, we might eventually use a web service to determine if the credit card is active, and if it's associated with the name and the address given here. By the way, the credit card number given here is not a working number. It was simply generated randomly by a website that provides such numbers for testing e-commerce sites. In addition to the extra validation needed from a web service regarding the credit card number, there could be errors in writing to the database, perhaps due to connection problems or bugs introduced by code changes. Recall that the transaction must be atomic. Therefore, either all the relevant tables in the database are updated, or none of them are. Let's assume that everything works out and the database is updated appropriately. If that happens, we are taken to the confirmation page. A confirmation number is given to the user and a summary of the transaction appears. After we have successfully completed this transaction, we should see that a new customer record has been added to the customer table with all the appropriate information. Likewise, a new customer order record has been added to the customer order table. It includes the confirmation number and it also includes a reference to the customer we just added. In this case, 2 new ordered product records have been added because 2 products were ordered. The milk, indicated here by ordered product ID 1, and the sausages, indicated here by ordered product ID 8. The quantity for each ordered product is 2 because we ordered 2 milks and 2 sausages. And the customer order ID associated with each ordered product is 2, which corresponds to the customer order record that we just added, which in turn has a customer ID of 2 that corresponds to the customer we just added.